In this video, we're going to be talking about an introduction to solids, which are three-dimensional shapes, identifying the types of them and some of the properties about them, and then using what's called Euler's formula. So this is said Euler. So let's take a look here. So you can pause the screen to get this written down. So polyhedron is the first thing, and what polyhedron is just a three-dimensional solid that all of the faces are polygons. Okay, so when you look at what's called the faces are just these kind of side pieces here. Okay, kind of this whole flat shape that you see. And so all of those need to be polygons, which means no curves. Okay, so no curves on any of these. And that's called a polyhedron. So then we've got the faces, which are just these kind of flat surfaces. You kind of see a bunch of triangles here. The edges are just where the two faces meet. So these are like line segments. Okay, so the edges are like line segments. So just this chunk right here. And there's a bunch in the back there too. But so like this would be an edge on this one, or an edge here. And then the vertices are where the edges meet. So these are points, okay? They're kind of like the prickly parts of them, like the corners of each of them. So the vertices are those little points or those little angles. So then here's the different types of polygons, again, or polyhedron. So again, go ahead and pause and get this written down. So a net is just a two-dimensional representation of a solid. So you could fold these up into different shapes, into different three-dimensional shapes. It's like you unfold or cut down the three-dimensional shape to lay it flat on a surface. And a prism, okay, so prism has two congruent bases, parallel bases, okay? And the base does not have to be the bottom of the shape. Okay, but when you take a look at this first one, hopefully you see this pentagon, and then all around the sides are rectangles, then you see another pentagon. Okay, so these are the bases, these two are the bases. And so you see the two pentagons, and then you see 5 rectangles, so those two parallel bases. This one, the base is a triangle. Okay, and it's kind of the overarching shape of the whole shape. You could just slide it back and get that whole shape. And then this prism, any of these could be bases because all of the sides are rectangles. So you could look at these two as bases if you wanted, or you could look at the ones it's sitting on. Okay, the actual one that's on the bottom you could look at as the base. Okay, so if this one is your base, then this would be the top base. So prisms have 2 bases. Pyramids only have 1 base. Okay, so they've got this base, and usually pyramids are sitting on their base because the other side is a point. So you're not going to see it flipped over sitting on a point more than likely. Okay, so pyramids are generally oriented with their base on the bottom. But they have 1 base, and then all of the sides, all of these what are called lateral faces, go up to a point. Okay, and so all of those lateral faces are triangles. Versus these ones, all the lateral faces are rectangles. So you've got a triangular base here, you've got a square base here, or a rectangular base. We've got a pentagonal base here going up to a point. And a regular pyramid means that the base is a regular polygon. So a regular pentagon would have all sides being the same, all angles being the same. Then if the base isn't a polygon, okay, if it's a circle, so remember a circle isn't a polygon because of the curve. So then you get a cone. So a cone is a one-based, or one circle as the base, right? So this is very similar to pyramids, just with a circle base. And then a cylinder is like a prism, but just with 2 circular bases. Okay, so this one is very much, it's going to act identical to a pyramid, and a cylinder is going to act identical to a prism. All right, then let's take a look at Euler's formula. Okay, so Euler is a German mathematician who found a relationship between the number of faces, the number of vertices, and the number of edges. So this is the formula that he found, that if you take the number of faces plus the number of vertices, so you add those together, that will always be 2 more than the number of edges. Okay, so you'll always be able to then, when you add these together, and then you do the edges plus 2. So faces plus vertices is always 2 more than the edges. So let's take a look here. If we know these, if we know this information, we can solve for the missing amount here, okay? So faces plus vertices equals the edges plus 2. So let's take a look in this one. So faces is 10 plus the vertices, which is 6, equals your edges plus 2. So 16 equals your edges plus 2. So subtract 2 from both sides, and you find out that the edges are 14. So there are 14. If there are 10 faces and 6 vertices, there's 14 edges. Next one, so faces plus vertices equals the edges plus 2. So then we have n plus 8 equals 17. So subtract 8 from both sides, and you get 9 for the number of faces. Faces 12 plus vertices, which we're looking for, equals the edges plus 2. So 12 plus n equals 22. Subtract 12, and you'll get that the number of vertices is 10. All right, then let's take a look at actually naming these. So one way to name it is based on the number of bases. So making it a pyramid or a cone if it's 1 base, or a prism or a cylinder if it's 2 bases. And then remember the polyhedron, all of the faces need to be polygons. So in order to be a polyhedron, it can't have any curves. So when we take a look at this first one, this has a curve. So this is not a polyhedron, but we do in fact know the name of it. It is a cone. This next one has all polygon faces, right? We've got this rectangle on the bottom here. All of these are triangles. So this one is a polyhedron. It comes to a point, so it has 1 base and goes up to a point, so it's a pyramid. And what type of pyramid it is based on the base. So this one has a square base, so you could call this a square pyramid or a rectangular pyramid. Okay, so you name it based on pyramid or prism, and then also the base shape. Now this one, okay, has 2 parallel bases. And this one's actually a little bit special because it's all squares, okay? All of the faces are squares. So you could call this a prism, okay? Number one, it's a polyhedron because it's all square sides. So you could call this a rectangular prism, but more specifically calling it a cube because all of the sides are identical. Polyhedron for D, yes, because all of the faces are polygons, okay? It stays a uniform shape all the way through instead of going up to a point, right? So this is a type of prism. And the uniform shape that we see because of these bases, so these have, it's a triangular base. Okay, remember the base, it doesn't have to be sitting on the base. It's what shape does it stay overall. It doesn't stay a rectangle all the way up. It stays a triangle from side to side or base to base. So this is a triangular prism. Polyhedron for this next one, yes, there's no curves. Okay, it is sitting on its base. Okay, we can see this base repeat itself on the top. So this has 1, 2, 3, 4, 5, 6, 7 sides. So this is a septagonal, or you could say heptagonal. Septagon, heptagon are both 7 sides. Septagonal prism. Next one, not a polyhedron because we see the curves. So we see the circular bases, 2 bases, right? So this one is a cylinder. G, yes, it's a polyhedron. Okay, it is a type of pyramid since it goes to 1 base. The base is a triangle, so it's a triangular pyramid. Polyhedron for H, yes. Okay, it could be any of these bases since they're all rectangles. So this is a rectangular prism. And any of those could be the base. So if you want these ones to be the base, that's fine. Polyhedron for I, yes. Base shape, 1, 2, 3, 4, 5, 6 sides. So this one is a hexagonal prism with those two bases. Okay, two bases in this next one, all faces polygons. 1, 2, 3, 4, 5 sides there. So this one is a pentagonal prism, since it's got the two bases, does not go to a point.